10th CBSE Chemistry, Chapter Periodic Classification of Elements. In this video, you will learn the modern periodic law and also the reasons behind the periodicity of elements which we observed so far. Observe the periodic table. Yes, this is the modern periodic table in which the elements have been arranged in an increasing order of their atomic number. Now let's have a closer look at each element. Like for example, hydrogen. We can see that inside the box there is a symbol of hydrogen, name of the element, that is hydrogen. On the top you can see there is 1. It means that 1 is the atomic number and 1.008, which is the mass number of the element. Now this is same for the other elements listed in the table, whether it is helium, lithium, beryllium or radon. Now let's observe only the atomic number of elements. Hydrogen has atomic number 1, helium 2, lithium 3, beryllium 4 and boron 5. And this continues in the increasing order and the order increases by 1. So the difference between the first and the second element in the atomic number is only 1. You take any two elements from the list, it is same for that. Like for example, calcium and scandium. Calcium has an atomic number 20 and scandium 21. So we see that there is an increase in the atomic number in a regular way. That is, each atom has atomic number which is greater by 1 units than the previous one. Now let us observe the atomic masses of the elements. Hydrogen has 1.008 as the atomic mass, whereas helium, which is the very next element, has the atomic mass of 4.003. Lithium has 6.941, beryllium 9.012 and C boron it is 10.811. If you take any two elements from the list, like for example iron and cobalt, iron has 55.933 whereas cobalt 58.933. Now the observation here is that we don't see the periodicity in the atomic masses of elements. It means that there is no continuation. Atomic numbers of elements showed periodicity, whereas the atomic masses of the elements always changed. Now this is a very important observation which a young scientist called Henry Moseley figured out. Based on all these observations, Henry Moseley proposed the periodic law. Modern periodic law states that properties of elements are a periodic function of their atomic number. Properties of elements are periodic function of their atomic number. The modern periodic law resembles the periodic law proposed by Mendeleev, but there is a small change, and the change is the atomic number. Yes, instead of atomic mass, it is the atomic number which decides the properties of elements, and because of this we can see a periodicity in the function, the properties of elements. This modern periodic law, which is based on the atomic number, is the basis of the modern periodic table. Modern periodic table is built on modern periodic law. Now let us understand what causes the periodicity in elements. Observe here, the first row gives the atomic number of the elements, the second row gives the element name in symbol form, and the third row gives the electronic configuration. Now here you can see the atoms are listed from lithium to neon, and observe the atomic number. It is continuous 3, 4, 5, 6, 7, 8, 9 and 10. Now below that you can also see their electronic configuration. So lithium has the atomic number 3, so its electronic configuration is 2 and 1. Beryllium has 4 as the atomic number, so its electronic configuration is 2 and 2. Boron has 5, so it is 2 and 3. Carbon 2 and 4 as it is 6, nitrogen 2 and 5, oxygen 2, 6, fluorine 2, 7 and neon 2, 8. Now the numbers which are denoted in red give you the electronic configuration of the outermost shell, the last shell of the element, and this comprises the valence electrons, the electrons in the outermost shell. All the numbers which are marked in red are valence electrons. So valence electrons are nothing but electrons in outermost shell. So outermost is the last shell of the atom. So you can see there is a periodicity in that also. 1, 2, 3, 4, 5, 6, 7, 8. Now let's go to the next period. This is the first period. Okay. The elements listed here are nothing but the elements of second period or period 2. And here we see the elements of third period. So we can see that they are one below the other in the periodic table. Now below lithium you have sodium and see its atomic number, it is 11. Now when we write the electronic configuration, it is 2, 8 and 1 because it is having 11 electrons. So when we distribute the 11 electrons among different shells, K, L, M, N like that, so it is 2, 8 and 1. It is same for magnesium. With the atomic number 12, it has got electronic configuration 2, 8 and 2 and it goes on. Now observe here. Here also we see that there is a periodicity 1, 2, 3, 4, 5, 6, 7 and 8. So there is a periodicity in the outermost electron number. Outermost electron number, that is the valence electron along the period. There is one more important observation you have to make. How many electrons are there in the outermost shell of lithium? It is 1. How many electrons are there in the outermost shell of sodium? It is 1. See, lithium and sodium. Lithium and sodium both have 1 valence electron. Now observe beryllium and magnesium. So yes, it is 2 valence electron. Okay. And if we take boron and aluminium, it is 3. Carbon and silicon, it is 4. Nitrogen and phosphorus, it is 5. Oxygen and sulfur, it is 6. And fluorine, chlorine, 7. Neon and argon, completely filled outermost orbital, that is electron number 8. Now, do you observe any pattern here? Down the group you see that the elements have similar number of valence electrons. That is, they have the same number of valence electrons in their outermost shell. So because of this, the chemical and the physical properties of these elements will be similar. It is same for all other groups. This is the reason why Mendeleev also wanted to place elements of similar chemical properties one below the other. But then Mendeleev did not have an answer as to why they showed the periodicity. By keeping the atomic number as the basis, when modern periodic table was built, scientists could explain the reason for the periodicity of elements. Now you must have understood why atomic number becomes very important in classification of elements. Construction of a periodic table based on atomic number did not only give an explanation for the periodicity of elements, it also solved many other ambiguities which Mendeleev couldn't answer. Now let's do a quick recap about what all we learned in this video. Modern periodic law. Modern periodic law states that the properties of elements are the periodic function of their atomic number, and the periodicity of elements are due to the similar valence electron number which occur at regular intervals. The modern classification of elements relates periodicity in properties of elements to the periodicity in electronic configuration. In this video, you learned the modern periodic law and the reason behind the periodicity of elements.